Part 2, we are measuring the volume and mass of a solid and then determining its density by taking the mass and dividing by its volume. So there are 3 different ways that we're going to determine the volume of the solid. The mass is always determined by the balance, and we always want to start with that balance at 0.0, place whatever we are determining the mass of on the scale, and record exactly what the balance says. So our first method of determining the volume is direct measurement, and we will record that data in data table 5, and of the magnet we will, or you will, record its length, width, and height using your centimeters ruler with 2 places after the decimal point. You'll multiply these 3 together to get the volume in centimeters cubed, and remember, your volume will have as many sig figs as the measurement with the least amount of sig figs. And then your density will be mass divided by volume, and again, your density will have as many sig figs as the least amount of sig figs. So if your mass only has 2 sig figs and your volume only has 2 sig figs, then your density will only have 2 sig figs. The next way that we're going to determine the volume is through water displacement. So again, you will measure the mass of the magnet and record its mass in data table 6. Then you're going to fill your graduated cylinder, well, not fill it, but place the graduated cylinder with water so it's to 6 to 8 mils, and then record the volume to the correct decimal place. So if you can read the ones place on your graduated cylinder, you will estimate the 10th place. Then you're going to carefully slide the magnet into the graduated cylinder so the water doesn't splash out, and read the volume now. And it will be higher than it was, and it will be just as high as whatever volume the magnet took up. So in data table 6, you will record the initial volume of the graduated cylinder, the final volume after the magnet is placed, and you subtract the 2 to get the volume of the magnet. And then to get its density, you take mass, divide it by the volume in milliliters. And we'll do the same thing for the metal bolt. You cannot calculate the volume of the metal bolt because it's not a regular shape. So water displacement is one of the few ways that you can calculate the volume and thus the density of the metal bolt. The last method is Archimedes' method. And this is a little bit confusing and sort of not very accurate. You're going to tear the scale so that it's 0. You're going to place the metal bolt on it, measure its mass, record that mass in data table 7. And then to figure out the volume, what you're going to do is you're going to use the mass of displaced water. So this is a little bit tricky. You've got to tie your bolt around with a string, place it in the beaker so it is totally submerged, but it's not touching the bottom. You need to hold that string, and what the scale is supposed to read is the mass of the water that was displaced by this bolt. And because water has mass that's equal to volume, in that 1 gram is equal to 1 milliliter, the mass of displaced water is going to be equal to the volume of displaced water. So whatever your change in mass is on the scale, that's actually going to be the change in density. This is a pretty terrible way to determine volume, and your data may show that, but we're going to go through this anyway. So on data table 7, we're going to have the mass of the magnet and the metal bolt, and then you will tie both with a string, place it into the beaker without letting it touch any side of the beaker, and calculate the volume of the displaced water by the mass of the displaced water. So the new mass of the water after the magnet or the bolt was placed in it is going to be the mass of the displaced water once you subtract the original mass of the magnet and the metal bolt. And then you'll calculate the density by taking the original mass divided by the volume of displaced water. So your displaced water volume, just to be sure, is going to be the difference in mass between the mass of the water on the scale and the mass of the water once you added the magnet or the metal bolt with the string. So that difference is going to be the mass of the displaced water, which is equal to the volume of the displaced water. So if your final density does not match those from the density that you calculated in Table 6. Don't fret. The Archimedes method is just really not that accurate. And on these sample exercises, you do not need to answer questions 3 and 4.